This is my dust port solution for this Ryobi 1600 watt router. It replaces this original part, which does actually work quite well, but is very brittle and prone to cracking. You can see here that it's already cracking, and that's with fairly minimal use. Let's just say that you need to be super careful when using the original part to avoid breaking it. So far, I've been really pleased with the way this new design works. I've designed it with a horizontal hose fit, which I think keeps the hose out of the way and makes things easy to see. This part is designed to work specifically with my Festool dust extractor hose. The internal diameter is 36mm and works with a simple push fit, no bayonet design for this one. When in place, the design still allows the maximum amount of plunge depth. So what about addressing that issue of strength? Is this design more resistant to breakage in normal use than this original part? And I say normal use because I'm about to bash this thing around a bit, which you probably wouldn't normally do. Here you can see test print 10, which is made with tough resin. It's holding up to twisting forces fairly well. And you can see some of the other test prints in the background, and I'll get to those in a moment. But what about smashing it with a hammer? Now, you probably don't go around smashing tools with hammers when you're in the workshop, but it makes for a fun test. I'm using my normal method of just dropping this 3 kg hammer on it with its own weight. Here's test number 1. Well, that's quite a good result. Let's try that again. Okay, so it breaks if you really try to break it. But I did make further improvements, and I'll come back to those in a moment as well. So stick around to see further strength tests. To install the part, I used the same mounting screws that I used for the original part. And I'd have to say that the design Ryobi has used here is kind of okay. It works, but it's a bit awkward. Using the original screws, you need to tip the router on its side, insert the screws, and then try to match the screw to the tiny 4mm nut on the other side. This can be a little bit fiddly. But I've designed the hexagonal cavity on the dust port to be just the right size to make the nuts captive. This means that uninstalling it and then reinstalling it is much easier. The cavities are also not so tight that you can never get the nuts out again, so that approach has saved quite a bit of hassle. Once it's in place, it creates a nice seal around the opening where all the dust is created and still allows good visibility overall. Now, before I show you the further strength improvement that I made, I'd like to quickly share a bit of the design process that went into this. The first challenge was to replicate the shape of the opening in the router. It's kind of a weird rectangular oval shape, and because I don't have the original plans for the router, I had to reverse engineer it. I used Shaper 3D to create the model, and the first part involved running some test prints to get that initial shape right. This actually took less time than I thought. Once I got that part right, I could extend the design to create this dome shape. The hole in the top is the same size as the hole on the original part. Now, the next challenge was to connect that part, the part that takes the hose, with the strange dome shape on the router. Now, this rectangular shaped duct seemed to work quite well and created a functional interface between the two parts. Now, this is when I started printing multiple test prints to get this right, and to know that the printing process was reliable and repeatable. I used PLA at first because the process is quicker, but the print quality isn't that great on a shape like this. And then I switched to resin, and I started with some eco resin, which I happen to have plenty of. And you can see here that eco resin is far too brittle for this application, but I knew that from the start. I was just using that for prototype testing. And here they all are. Now, you might be wondering why I printed all of these different tests. That was because I was experimenting with different printing positions on the build plate and trying to refine the process to be as easily repeatable as possible. Many of these are broken because eco resin is very brittle, and it was interesting to see that it broke in the same place almost every time. You can see from this print that there's quite a bit of support material to make this print happen and to keep it firmly connected to the build plate for the whole print. Getting this right can require a lot of testing. And by the way, each print takes about 8 hours, so we're over 100 hours of testing once you factor in all the PLA prints as well. Now, once I got to a predictable resin print, I then switched to this white tough resin. That was with print number 9. And in this print, number 11, you can see that there is still the same failure point where the duct connects with the dome, although it takes much more effort to break it. This is version 12. Now, to provide further resistance to breakage, the thickness has been increased by 0.5mm in the rectangular duct and on the dome. And the corners where those parts are joined have been reinforced with fillets, adding just a little bit more resin without the whole thing becoming too bulky. So how does version 12 stack up? Well, I'm not going to smash this one with a hammer. Instead, I tried to simulate some fairly rough usage when it was actually installed in the router. Now, I wouldn't recommend throwing your router around like this either. It's probably not that great for the internal parts, and I was a bit concerned about throwing the spindle off center, if that's even possible from handling it this way. You can see here that it will take quite a bit of punishment, unlike the eco resin or the original part, which will break easily in your hands. But if you try hard enough, it will break. Now, is that okay? Well, kind of. Because if you're handling all your power tools like I am in this testing, it's likely that you'll be breaking a lot of other things too. Perhaps a different hobby might be more appropriate. Like yoga. Maybe. Anyway, this has been a great improvement to this router, and I've really enjoyed using it. So much that this first design is good enough to receive the Mark I label. And yes, I have considered ways to make it even more break resistant. But then I'm not really trying to create something that's indestructible. I am also considering using translucent or clear resins in the future. Maybe for Mark II. Now, if you'd like more information, or perhaps you'd like to get a hold of one, then check the link in the description below for details. And if you got value out of watching that, then please consider leaving a like and subscribing. And with that, I'd like to say thank you so much for watching, and we'll see you in the next one.